Hello students, I hope you are well and doing well. Today this is my second lecture on integration by parts. In the previous lecture we have already discussed what is integration by parts. Now to get more clarity related to integration by parts, we will do more questions so that more clarity we get. So let's start. So we have one of the question is ex in the bracket 1 upon x minus 1 upon x square. So this type of question is special one. Let's see how. Ex into 1 upon x dx minus 1 upon x ex we have by multiply. Now one of this 1 upon x, another one is minus 1 upon x. So on one of these two, one is derivative of other. In this question, 1 upon x is derivative of minus 1 upon, 1 upon x have derivative minus 1 upon x square. Let's see how. 1 upon x we can write this. So minus x minus 2, we can write this as 1 upon x square. So whenever there is question ex exists with two things, one is derivative of other, so we will solve only one part by integration by part. Let's see why. Because otherwise it's not solvable. We are not in the condition that we can solve if we will continue solve both the part. So we will solve only one part. Which one is not derivative? No. So this is derivative part, we will leave this as here, so only integrate this one. So as our islet I L A T E, according to islet E exponential, so this one is exponential ex, and 1 upon x is algebraic, so this is our algebraic 1 upon x. So algebra is first part, so we will take as first function, this as second function. So we will substitute this in our formula. So first function integration second, mean integration of ex, as we know ex, minus integration the derivative of first function minus 1 upon x square, and integration of ex, as we know ex dx, and we will write this part here. So this one is minus 1 upon x square ex dx. Clear? So this one is 1 upon x ex minus integration of 1 upon x, plus 1 upon x ex dx minus integration 1 upon x square ex dx. We can cancel these two because one is positive, another one is negative with same quantities. So ex upon x plus c. So this is our final answer. So what we have observed, we have created one of formula. With this we can directly tell the answer also. How? Suppose we have to find such type of question when ex exists with one is derivative of other, we can directly write as, suppose this one is fx, another one is f dash x, and multiply this one with ex, and we have to find integration of this. So the answer directly will be ex fx, as in the same case this one ex upon x. Now we will do next question. The same question this one, but it is not directly observable that we can see that this one is derivative of other. So we will create, or we can convert it into the derivative of one into the another. So let's start how we will do. We will first try to make the denominator and numerator look like same. So this one is x minus 3, we will write this one as x minus 1 and minus 2, and in the denominator we will write as x minus 1 and q. From here we will separate the denominator part as numerator have same. So this one is ex x minus 1 upon x minus 1 3 and minus 2 ex dx. Then we will separate these two, ex x minus 1 upon x minus 1 3 dx minus 2 ex x minus 1 cube dx. So we can write this as ex integration of ex upon x minus 1 square dx. Why? Because this one x minus 1 and this one is x minus s minus 1 power 3. We can cancel this one, so it is ex upon x minus 1 power 2. So this one is 2 ex x minus 1 cube. Now we are in the condition that we can write its answer directly, because 1 upon this one is 1 upon x minus 1 square have derivative as minus 2 x minus 1 3. So this has derivative here is exist as this one, so we can write this one as ex upon x minus 1, and even you can apply the eyelet on this part. We will write suppose we want to use eyelet, so we will apply on this part because this is it has derivative as exist this one. So if we are writing this as directly, so we will always mention that integration of fx ex fx ex, wait, just wait. So we will write this as a formula so that examiner can understand you have knowledge of doing this. So fx f dash x or ex product dx. So this is directly equal to always fx ex. Clear? So whenever there is e exist with any other term, so be careful, no? So try to, so don't try to apply eyelet on both the parts. If you have to be apply both the part, in never end. So leave the derivative part as in this part 1 upon x minus 2 square x minus 1 2 square, and in another part 2 upon x minus 1 cube is derivative of 1 upon x minus 1 square. So the same way we will do one more questions, this one. So in this case also we will convert it into derivative of one another so that we can easily solve this part. So how we'll do, first to understand or you can solve, we have one of the approach to use, or you can to understand. Suppose this one is written as 1 or sine 2x, and we can write as 1 as sine square x plus cos square x plus sine 2x, because as we know 1 is sine square x plus cos square x, then we can write this as sine square x plus cos square x, and sine as 2 sine 2 theta, as we know sine x plus cos x. Now we can write as this one is a square b square 2ab, so we can write this as sine x plus cos x whole square. So this is equal to 1 plus sine 2x. So in this case also we have 1 plus sine x, but only difference is here is 2 is missing. So we will convert this as 1 plus sine x equal to sine x by 2 plus cos x by 2 whole square. Why this? Because here is 2 and half of 2 is 1. In same case here is 1, so half of 1 is half and half. So in place of 1 plus sine x we will use this. We will use this here. We will set now. We will replace 1 plus sine x with sine x by 2 plus cos x by 2. I hope it's clear. Now I am using this one. So we will replace 1 plus sin x with our derivation. This one is ex, and we will write this as sin x by 2 plus cos x by 2 whole square. And as we know, 1 plus cos 2x equal to 2 cos square x. In this case, 2 is missing, so we'll write this formula as cos x as 2 cos square x by 2. So we will replace 1 plus cos x with 1 plus cos x with we'll replace 1 plus cos x with 2 cos square x by 2. Now we can write this as 1 upon 2 outside because it's constant. So ex sin x by 2 plus cos x by 2 upon cos x by 2 and whole square. We can write this as 1 upon 2 ex and sin x by 2 cos x by 2 plus 1 whole square, because we are separated this one sin x upon cos x and plus 1. Now this one is 1 upon 2 ex tan x by 2 plus 1 whole square plus c. So ex tan x by 2. Now this one is 1 upon 2 integration ex, this is whole square, tan x plus 1 whole square. We will open as a square b square plus 2ab tan x by 2. Now we are in the situation that we can convert one of them as the derivative of other. So we'll convert this as a derivative of other so that we can easily solve this. Otherwise we will again trapped if we have not find this as a derivative of other. So it will be very difficult to solve this one. So we'll convert this as a derivative of other. So how we'll convert this as a derivative? We will write as 1 upon 2 ex. As we know, 1 plus tan is sec square x by 2 and 2 times tan x by 2. Now this one is 1 upon 2 ex x by 2 dx. I am multiplying with 1 upon 2, so it is integration tan x by 2 ex dx. Now the derivative of this one is this. As we know, derivative of tan x is sec square x, but in this case this is tan x by 2, so it is sec square x by 2. Then derivative of x by 2 is 1 upon 2. So as we already have discussed that if we want to find out integration of fx plus f dash x and ex, so it will be always ex fx. Even you can apply the long method that you have to be integrate this one by integrate by part. So you will be this. So it's better to solve directly or write the formula because it take time. So directly we can write this as ex tan x by 2 is its answer. I hope it's clear to you. Now next one. In this question we have x square ex cube. So in this question there is x cube and we have x square. So as we know, x cube have derivative as x cube, put t as this one, So this is 3x square dx dt. We can write this one as x square dx 1 upon 3 dt. So we'll replace x square, this part, and dx with 1 upon 3 dt. We'll replace x square, and dx by 1 by 3 dt, because this is equal to x square dx equal to 1 upon 3 dt. So we'll write 1 upon 3 e t dt. So we can write, as we know, integration of ex is ex. So this is our answer. Now next we can write this answer directly. This is just for your revision, because ex into log x dx and ex 1 upon x dx. We have already discussed that if ex is fx plus ex f dash x, so always the answer is ex fx plus c. So in this case, log x have derivative. So log x have derivative 1 upon x. So 1 upon x if it has, so in this case the answer will be ex log x plus c by direct formula. Even you can apply the long method. No? Next, in the same this one is also, in this case also you can see this one is sec x, and sec x derivative is sec x. Suppose you have derivative of this one d upon dx, so derivative of this one is sec x plus tan x. So in this, suppose we have to find out integration of ex sec x plus tan x dx. So you will write this as directly ex sec x, because again I am repeating, if integration of ex, just wait, suppose I am again repeating so that it's clear to you. This one is ex fx plus f dash x, and we will write this as equal to fx. So it's different than other questions. So keep in mind, whenever ex exists with any other function, so always be careful. It may be ex plus derivative of one of another, and another one is ex, as we have in our previous lecture. So don't repeat this one. So be careful whenever ex is multiply or with any other function, or same in this case ex is multiple of and then plus. So in this case this one is derivative, and in earlier case this one is repeating. Suppose sin x then cos x then sin x cos x. So we have already discussed. So I hope it's understood to you. In the next lecture we will do next exercise. So thanks.